Hey guys, so I'm back with a new lesson and we are studying the electromagnetic induction. Here is a bit information about me. My name is Adarsh. I love teaching and you can follow me on this link shown on your screen. So, ladies and gentlemen, what is the second law of Faraday? So, Faraday's second law stated that the induced EMF is directly proportional to the rate of change of magnetic flux linked with a coil. So whenever there is a coil and when the magnetic flux linked with this coil changes, then its rate will give you the magnitude of the EMF produced in that coil. Okay, can you understand this? If the magnetic flux linked with a coil changes, then its rate will give you the magnitude of the EMF. So E is directly proportional to the negative of the rate of change of magnetic flux. Now what is this negative sign? This negative sign represent that this EMF will oppose this change. Okay, so whenever the flux changes, EMF will produce, and this EMF starts fighting with this change, and that EMF tries to oppose that change which is generating it. Okay, now so E is equal to minus d phi by dt. Now if the n is the number of turns, then all the turns equally opposes, or all the turns will have equally generated EMF. Okay, so the net EMF is due to the EMF generated in all the turns of the coil. So this can be written as E is equal to minus n d phi by dt, where n is the proportionality constant or the total number of turns presented in the coil. So simply one can say the rate of change of flux will be the equal to the induced EMF in a coil. For specific purposes, we say this is equal to the magnitude of the induced EMF. So the direction of the induced EMF is given by a separate law. It is not given by the Faraday's law. It is given by the Lenz law that we'll be discussing in later slides. Now, let us have a question. Find the number of turns associated with a coil in which flux is decreasing. Can you see this? This word is crucial, decreasing at the rate of 20 vapor per second. What does it mean? It means that d phi by dt is equal to minus 20. So you have to use minus 20 here. Okay, to produce this EMF. So you can put the value of EMF here. You can put minus 20 here, and the number of turns can be answered as 100 numbers. So please solve this and get to this answer. And yes, please let me know whether this answer is true or false. I don't know this answer is true. I just taken it as 100. Please let me know this answer is correct or not. If you solve the problem, you will get this answer. Maybe or maybe not. So please let me know this answer is correct, and please comment on the comment section what your answer is. Now, if we talk about this formula, E is equal to minus d phi by dt, which can be taken up from the Faraday's second law. So this can be interpreted in two ways, that E is equal to minus d phi by dt. So that what can be taken up from there is, whenever you have the phi and t graph, then the slope at any point of this phi and t curve will give you the induced EMF at that point. So this is very important. Whenever you have the graph of flux versus time, so go to any point wherever you want to, and wherever the question asked, the slope at this point will give you the induced EMF at that point linked with the coil whose flux versus time graph is given. Okay, now if we multiply E with dt by cross multiplication, then we comes to know that the integration from t1 to t2 of E dot dt will give you the change in flux. Okay, and this can be taken as the area under the ET graph will give you the change in flux. So this formula can be taken into two interpretation, that if the flux time graph is given, you can find the slope at any point to calculate the EMF at that point linked with the coil. And if you are given the ET graph, then you can find the change in flux linked with the coil for a particular time interval T1 to T2 by finding the area under the ET graph from in that interval T1 to T2. Now let us have some questions. So the first question says the flux linked with a coil changes from 20 Weber to 40 Weber in 0.02 second. Calculate the induced EMF. So we know that E is equal to minus delta phi by delta t for a considerable change in phi. So we can write it as minus phi 2 minus phi 1, where phi 2 is the final and phi 1 is the initial. T2 minus T1. We can put the value of 40, 20, and it comes out to be 10 raised to power 3 volt. Okay. Now the second question. If the initial flux is 20 Weber and the EMF generated due to the change in flux is 20 volt in 0.2 second, then what is the value of the final flux at this time? So again we've put this formula, E is equal to minus change in flux upon change in time. So the value of E is given as 20, we can put it here, minus final, we have to calculate that the initial is given as 20 upon my time is 4 into 10 raised to power 10. So by calculating this, we will come to a number phi is equal to 12 Weber. So can you imagine, if the EMF is coming out positive, obviously if the EMF is coming out positive, it means the flux is going to be decreased. So it comes as a decrement of 8 Weber. Okay. Now the question number 3, if phi is equal to 3t square plus 2t, find the EMF at t is equal to 2 seconds. So we know that if this kind of question is given where phi is in a function of time, then we have to find the slope at t is equal to t, and to find the slope at t is equal to t, we have to differentiate it. Okay, so E is equal to minus n d phi by dt, n is given as 2 and d phi by dt, you have to differentiate it. So when you differentiate it, it comes out to be 6t plus 2. By putting the value at t is equal to 2 seconds, will come out as a EMF of minus 12 volt. Okay. Now, question number 4. It is up to you to solve, and please comment the answer in the comment section. I can read the question for you. If the flux is 4t square minus 2t, then find the EMF at t is equal to 0.2 seconds. It is very easy question. You can find it out. Now, on the second interpretation of the formula, if the flux is if the EMF is changing as time E is equal to 2t, then find the flux at t is equal to 4 seconds. If the initial flux was 200 Weber. Okay. So E dot dt minus d phi by dt, you can interpret this from the second law, and by calculating this integration will come out to the final result at 184 Weber. Okay, so I hope you enjoyed the lesson, and you learned something, you gained something very good from it, and I advised you, whether or not you understand this lesson, please see it once again to understand how the question is to be tackled. Okay, and then go to SC Verma and solve the initial problems from 1 to 1 to 10. You can solve from 1 to 10 or 15, so that you will be able to tackle this type of question, and then we can move on the next lesson to understand the direction of the induced EMF by the Lenz law. Okay, so if you like the lesson, please rate, review and share. Thank you.